there was a big, bright sphere in the sky, the sun, and at night, lots and lots of far smaller points of light in the sky, the stars. It turned out the sun is a material object, made of matter, the same as the ground beneath our feet and the air we breathe. Eventually, humans learned that, like the sun, the Earth is also round. But, unlike Earth, it is extremely hot and luminous. And this difference is because of the sun's gigantic size. It is millions of times bigger than the Earth. With more mass comes more gravity. In its early history, almost all of the matter in our universe was hydrogen. Hydrogen is a single proton, orbited by a single electron. Much of this hydrogen then coalesced to form the first stars, most of them much larger than our sun. Deep within these early stars, airy hydrogen atoms were crushed into each other, combining to form into such things as iron, copper, nickel, and gold. And, important for life, carbon. Carbon's ability to interact in so many ways with so many other atoms makes the complex biochemical processes of life possible. This is why life as we know it here on Earth is referred to as carbon-based life. However, carbon in the middle of a star could never go on to form into living things. But, fortunately for living things, the very large stars of the early universe would commonly explode in spectacular fashion, in what's known as a supernova explosion, and jettison the heavier, life-giving materials lodged within them into the vastness of space. So, such different and varied things as oceans and mountains and forests all have their origin in airy hydrogen, fused into heavier elements in right-sized stars in the early history of the universe. Some of their jettisoned material coalesced through gravity into second-generation stars, like our sun, and some of it coalesced into rocky planets, orbiting around second-generation stars, like Mercury, Venus, Earth, and Mars. And some of it is still careening about, way out in space at tremendous velocities, from spectacular supernova explosions, eons and eons ago. At this location in northern Arizona, a fortress-sized object made of metal crashed into the Earth some 50,000 years ago. In terms of the history of life on Earth, not that long ago. Earth's active atmosphere and plate tectonics erase most evidence of such impacts. However, without these events, Earth's surface might look much like that of the Moon or of Mars. The red planet retains abundant evidence that impacts are common throughout the solar system. In fact, the collision of a string of objects with planet Jupiter was observed directly by scientists back in 1994. The impact site they carved out was many, many times bigger than the size of the Earth. It is probably impossible to think about asteroid, comet, and meteor impacts without thinking of the dinosaurs. There is a trace element found often in extraterrestrial objects, but found only extremely rarely here on Earth. This element was found in overabundance in sedimentary layers, dated to about 65 million years ago. And this is exactly when all dinosaur fossils suddenly disappear. Tyrannosaurus and Triceratops were very large and very different from anything that exists today. However, I can see Triceratops as a kind of dinosaur-age buffalo, a bulky, low-lying grazer with horns to protect itself. Tyrannosaurus, on the other hand, is almost totally incomparable to today's animals. Today's apex predators are the great cats and bears and wolves. They're all four-legged animals. So why were Tyrannosaurus and other animals like it all upright walking predators? Well, it turns out there had been a major mass extinction some 250 million years ago, the worst ever in the history of life on Earth, far worse than the one from 65 million years ago that ended the age of dinosaurs. And before this worst ever mass extinction, there had indeed been a lion or wolf-type predator, a four-legged beast with fangs. And in this worst ever extinction event, the lion or wolf-type four-legged predators died out, as did about 95% of all species on Earth. These are called gorgonopsids, and they were what's known as mammal-like reptiles. Certain features of the skull and teeth link them to creatures more related to the ancestors of mammals, and not related to the ancestors of dinosaurs and today's reptiles. What you're looking at here is not the skull of a lion, but rather a lion-like animal that lived before the dinosaurs. Evolution took a sharp turn when these and most other animals went extinct, most likely due to a series of severe volcanic eruptions, creating the geologic formation known today as the Siberian Traps. A massive volcanic deposit, a large portion of the surface of the Earth, smoldered like hot embers for tens or hundreds of thousands of years. The planet became much hotter. The atmosphere became full of noxious vapors and carbon dioxide. And the oceans became so hot that the temperature-driven flow of their currents came to a halt. Without circulation, the world's great oceans became poisoned, and almost all of the animals of the oceans perished. What scientists think is that dinosaurs evolved from a small animal that managed to eke its way through this terrible cataclysm. It had proportionately large hips and leg muscles, a fairly long neck and skull, and arms adapted for grasping rather than four-legged running. This small animal probably used its muscular hindquarters to leap at small prey, and certainly would have walked upright on two legs. Its skull had a large opening between the eye socket and nasal socket, making it lighter for leaping. Later, Tyrannosaurus and all other dinosaurs would be distinguished by this opening. This animal then developed and diversified without much competition to fill different roles and niches in nature. In other words, into all of the two-legged T-Rex type dinosaurs and all of the long-necked, four-legged Brontosaurus type dinosaurs. They all share a common ancestor in this two-legged leaping animal. Some mammal-like reptiles made it through as well. During the Triassic, there was a mammal-like grazer, but the mammal-like reptiles would not go on to achieve the dinosaurs' success in numbers, or in diversification to prominence in so many of nature's spheres. The age of dinosaurs was a long one. However, volcanic eruptions were again stressing the environment 65 million years ago, and most scientists now believe that dinosaurs were already in decline when a mountain-sized space rock slammed into the Earth off the eastern coast of what is now Mexico. However formidable the dinosaurs may have been, they lacked an important ability that was beginning to appear in the ancestors of today's most prominent creatures, the mammals. The retention of developing offspring within the body of the mother, where they would be safe from predation and then nourished by mother's milk. Hard-shelled eggs were an important step in the forward progression of living things. They are what allowed animals to breed on land for the first time. And this was still cutting edge 250 million years ago. But by 65 million years ago, nature was beginning to find a better way. Why these solutions developed in the ancestors of today's marsupials and mammals, and never in dinosaurs or birds, is hard to say. And one has to wonder, what would have happened had the large mountain-sized meteor or asteroid not hit the Earth at that moment 65 million years ago? What one can say about it is this: the ancestors of today's mammals would have almost certainly had an advantage over time. For whatever reasons, dinosaurs seem to have not been able to develop these improvements, and even birds, their related descendants of today, still lay eggs, though usually way up in trees where they are much safer. When the mountain-sized meteor of 65 million years ago struck the Earth, evolution again took a sharp turn. The descendants of the mammal-like reptiles made it through this second great cataclysm, and their reward is the opportunity to spread and diversify into all of the myriad forms of mammal life we see today. Everything